I work with Northwest Local Land Services. I work in the Natural Resource Management team, but I'm also a farmer. So this sort of information is really relevant and important, not only to me, but to everyone on online. And I think you'll probably have all heard in the news updates in the last week or so around the El Nino watch. So you'll hear a bit more about that today. First of all, I'd like to welcome to country. I acknowledge the traditional owners past, present and emerging. I'm joining you from Bigabul country at Gundawindi today, and I acknowledge all of the countries and nations from which everyone's joining us from. So first of all, we've got Tim Cowan presenting. He's a research fellow at the Centre for Applied Climate Sciences in USQ and is embedded within the Seasonal Climate Processes team within the Bureau of Meteorology. Prior to working with the Bureau, he worked with the CSIRO for 10 years and he researched Indo-Pacific climate variability and its influences on Australia. And more recently, he's completed a postdoc at the University of Edinburgh, focusing on early 20th century climate extremes. Tim's research is centred on developing prototype forecast products to help the northern cattle industry better manage drought and climate risks. And just before I get Tim to take over and start, I just also would like to acknowledge the support of the Northern Australia Climate Program and the Southern Queensland, Northern New South Wales Innovation Hub, of which I represent the Narrabri node. So yeah, thanks, Tim.
Thanks, Pippa. Let me just share my screen. Usually this goes off without hitch, but maybe a first. Okay. Just gonna, I assume people can see that okay? Thumbs up if you can. Yep. All right, brilliant. Now, thank you very much for that, Pippa, and thanks everyone for attending today. So, yeah, so what I'm going to be talking about the next 15 minutes or so is what is El Nino and what is its impact on southern Queensland or northern New South Wales. I'm talking about rainfall here and temperatures. And what is this thing we call El Nino Modoki, also known as Central Pacific El Nino? So on the left, this bottom left here, we have a picture of what El Nino might look like. It's like a border collie. And on the right, we have what an El Nino Modoki might look like. And that's my dog on the right. And he looks a bit like a border collie, but he's not a border collie. He's actually an Aussie Shepherd. So, and when he rolls in fox poo, he becomes a different beast altogether. So we'll come back to Modoki later in the talk. So let's turn to the Pacific Ocean. And this is an image of or a schematic of what the Pacific Ocean typically looks like. So we have in the western part what we call the Western Warm Pool. It's we see surface ocean temperatures reach about 28 to 30 degrees there. We have the trade winds that blow from the eastern equatorial Pacific through to the west. And that brings all this really nutrient-rich cold water from the subsurface up to the surface in the eastern side of the Pacific. That means it's great for fishing if you're into that, if you're a Peruvian fisherman. And then we have, along with these trade winds, we have this thing called the Walker circulation. And typically, it says over Australia that we have no influence during this sort of setup, but we do have an influence. I mean, the Pacific Ocean does influence our weather and climate. So when we have an El Nino event, what tends to happen then is that those trade winds that go from the east to the west, so we call them easterly trade winds, they start to weaken. And that warm water that's typically in the western side to the north of Australia starts to shift its way across to the eastern side of the Pacific. So, and that typically then weakens those trade winds further, and that warm water sort of piles up in the central to eastern Pacific. And that typically means you get what we call increased convection, so more cloudiness and increased chance of rainfall over the central and eastern Pacific. So flooding around Peru And in our neck of the woods, across Eastern Australia, it typically means that we get drier than normal conditions. So that does raise the risk then of, say, to the north of us, increased smoke risk when they do the burn off in the dry season across Indonesia and the maritime continent, and it also raised the risk of bushfires in the southeast of Australia, as shown here, and also poor fishing for the poor Peruvian fishermen across the eastern side. So this is what an El Nino event looks like. So on the left-hand side here, we have what we call a sea surface temperature anomaly map. So this is just the deviation of ocean temperatures, either warmer or cooler than normal. So when it's red or yellow, that's warmer than normal. And when it's blue, that's typically saying it's cooler than normal. And this is spring of 1982. So here we see that warm water piling up in the central to eastern Pacific. So this is a really strong eastern El Nino event. And likewise, we see around our area, we get this water that starts to cool off, and it comes around 2 to 3 degrees cooler than normal. And then we look at what the rainfall impacts were during the springtime of 1982. This is when I was only 2 years old, so I don't remember it. But what we found was that rainfall across pretty much most of eastern to central Australia was below or very much below average. And then if we remember back that far, there were the really terrible bushfires in Ash Wednesday of 1983. So as I said, you typically get a higher increased risk of bushfires after an El Nino event. Another event was in spring of 1997, 1998. So this is showing the same sort of thing now, another sea surface temperature anomaly map of the spring of 1997. And again, we see this warm water piling up in the eastern side of the Pacific and that cooler water around Australia. But unlike 1982, what we found was that the spring rainfall during the spring of 1997 was not lower than expected. In fact, for southern Queensland and northern New South Wales, they saw average to above average rainfall. So every El Nino event is different and there are different impacts. What we also see is that after an El Nino event, like in 1997, 1998, global temperatures actually tend to peak. So we saw this in 1998, record temperatures across the globe, and this includes both the land and the ocean. This is just what we call a time series going back from 1930 through to 1998, and we see this really strong peak in global temperatures after that strong Eastern Pacific El Nino event. So again, this is what the Eastern Pacific El Nino events typically look like. There's piling up of warm water in the east, and you get this convection and increased rain over the east. And then where we are in the Western Pacific, we tend to get drier conditions, typically. But we also have this thing called the Central Pacific El Nino, also called El Nino Modoki. And that's where that warm water, instead of piling up in the Eastern Pacific, it tends to sit around the Central Pacific, around the date line. And then instead of having this one big, what we call cell of the atmosphere, we get these two cells, and you get increased convection in the Central Pacific. And where we are in the Western Pacific, it tends to get really dry. And we saw this in the spring of 1991. So this is, again, another sea surface temperature anomaly map showing these warmer ocean temperatures really more towards the Eastern Pacific and really narrow along the equator. And then on the right here, showing that spring rainfall, the conditions for the spring, pretty much most of Eastern Australia experienced below average to very much below average rainfall. And then another one in 2002, which was really severe for Queensland and New South Wales. So again, these warm ocean temperatures stretched pretty much along the central, almost to the Eastern Pacific, but we saw almost, it was record-breaking spring rainfall deficits across much of Queensland. So what are the typical impacts of El Nino on summer rainfall? So what I'm going to be showing you now is a bunch of El Nino events that we sort of average the conditions over. And then we do this going back to the start of the 20th century. And you'll be surprised to see that the typical impact of El Nino on summer rainfall, as shown by this map here, for southern Queensland, northern New South Wales, is that you typically get average or average rainfall during the summer months. So I'll use an example here. St. George, during an El Nino event in summer, they typically get about 170 millimeters of rainfall across those 3 months. But if you look at all years, so including El Nino and La Nina and neutral years, they usually receive around 183. So it's only slightly less on average during an El Nino. But if we now look at the impact of El Ninos on spring rainfall, you can see by this map here. So these are what I was showing before. There's a decile map. So we take all the rainfall from all the springs going back to 1905, and we rank them, and where they occur, they can either be well below average or well above average. And what we found that during an El Nino, typically much of Eastern Australia is in those lower deciles. So it means very much below average spring rainfall. So again, looking at St. George, during an El Nino, it typically receives around 84 millimeters of rainfall. But if you look at all the years, so all El Ninos, La Ninas, and neutral years put together, it typically gets around about 117 millimeters. So it's a fairly large deficit during an El Nino. So that's all El Ninos. What about that difference between El Ninos in the east and the central Pacific? So when we look at these two different types of El Nino events, what we find, looking at the right-hand side, and this is showing you an association between Central Pacific El Nino and rainfall and spring rainfall, we can see that these darker shades of brown indicate a much stronger relationship to rainfall. So it means the stronger the Central Pacific El Nino event, the greater the deficit in spring rainfall over pretty much most of Eastern Australia. Whereas for Eastern Pacific El Ninos, that rainfall deficit, or that relationship to rainfall, isn't as strong. So if we were to see an Eastern Pacific El Nino, say at the end of this year, which we're not sure, you might typically, on average, see that the rainfall deficit is, or the relationship is not as strong to rainfall as it would be for a Central Pacific El Nino. What about temperatures? So we've looked at rainfall, but the temperature is quite interesting. So what we find, showing maps here of, again, average winter and on the left, and average spring maximum temperatures during these El Nino events. Typically what we see is that, say, for a place like Moree in northern New South Wales, during an El Nino event, their winters are around about 19.3 degrees. That's on average across the June to August. Typically using all years as a sample, it's around about 19 degrees. So El Nino is a slightly warmer winter maximum temperatures. For spring, it's a little bit warmer in a place like Moree. So it's about 28.3 degrees during El Nino events. When in any typical year, it's around about sort of 27.5 degrees. So what we're seeing is that winter and spring daytime temperatures, or maximum temperatures, typically slightly warmer during El Nino events. Whereas we look at nighttime or minimum temperatures now, again showing winter on the left and spring on the right. For a place like Moree, say in the middle of winter in July, during an El Nino event, you typically see minimum temperatures around about 3 degrees, whereas normally it would be about 4 degrees. So it's about 1 degree colder in the middle of winter in a place like Moree. And that increases the risk of frosts. Whereas once we turn into spring and we start to see those days get warmer and even the nights get warmer, typically what you see is that El Niños produce warmer nighttime temperatures. Still pretty cold by any stretch of the imagination, but slightly warmer during El Niños than a normal year. And that signal is strongest over southern Queensland and northern New South Wales. So I'll wrap it up there because I think I'm almost at the end of my time. So what I've talked about is basically just this El Niño, because we're coming into we're likely to come into an El Niño now, as Chelsea will talk about in the next talk. It's the dominant climate mode in your region for year-to-year variability. And what I've talked about today is that El Niños typically produce drier and warmer days, but cooler winter nights. So there's that risk of frost. And that largest impact is actually in winter and spring, not in summer for your region. And I'll just finish it off there with this image here, which is a nice lead into Chelsea's talk, showing you the current forecasts for El Niño Southern Oscillation using a sea surface temperature indicator, which is called Niño 3.4, across all the modelling institutions across the world. And it's indicating there's a pretty strong likelihood of an El Niño towards the end of winter, start of spring. So I'll leave it there, and if there's any questions, I'm happy to take them, or likewise, I can respond to them in the chat as well. Thank you.
Thank you very much, Tim, for that. I always find those sorts of talks really interesting, particularly I think for me that the fact that on average, or generally speaking, El Niños have a bigger impact in rainfall in spring and not necessarily as big in summer, which is a really interesting point. You always sort of figure that El Niño will actually just make it drier across the board, when in fact that's not always the case. So yeah, you learn something new every day. Thank you. And one thing I forgot to mention at the start, we are having a Q&A session right at the end. So if you've got any questions, which I've noticed a few have been coming in, please pop them in the chat and we will do our best to answer those right at the end. So yeah, Tim, there's already a few coming your way, it looks like. Next speaker, I'd like to introduce Dr. Chelsea Jarvis. She is a research fellow at the University of Southern Queensland Centre for Applied Climate Sciences, focusing on communicating advancements in climate science to primary producers to assist in on-property management. She works closely with the pastoral industry across Northern Australia. So welcome, Chelsea.
Thanks for that. I keep getting the pop-up things and they block my whole screen when they pop up. Yeah, so everybody, thank you so much for attending today. Thank you for your time. Now we're going to start looking at the forecast. So Tim provided the background, you know, what's happening, what is this El Nino, La Nina thing? And now we'll take a look at the forecast and why they're showing what they show. So I'm going to go ahead and share my screen. If I suddenly get a little bit slow, my internet speed, not me personally, can somebody just let me know and I'll turn off my camera? I'm just having some internet problems today. So let me go ahead and share my screen. This one will probably look pretty familiar to most people. It is the Bureau of Meteorology website. So it's balm.gov.au, and this is the homepage. The place that we find our short-term forecasts, so for the next 7 days, is this MEDI, or you can look at the rain radars or kind of any of these, but these are the weather buttons up there. But if we scroll about halfway down, we see this climate and past weather. So this is where all those longer term forecasts are. So anything past the next 7 days, this is where you need to be looking. Okay, we're going to click on that. And we see there's a whole bunch of stuff here. Like this website's just a monster to look at. So it's really good to kind of bookmark things, and that way you get straight there. And what we're going to look at right now are these long range forecasts. Actually, that's a lie. I'm not going to start there. I'm going to start about halfway down where it says this climate driver update. and it says La Nina has ended, and so now neutral and El Nino watch issued. So let's just click on that just really quick, just to follow on from what Tim said. So if you're ever wondering what's going on with El Nino or La Nina or the Indian Ocean, if you know anything about that, or the Southern Annular Mode, this is where we find all that information. And so this is just a summary of what's going on in all of our oceans. I did see a question up there about, is El Nino only in the Pacific? And we'll get to that one later because I think that one's really interesting. But all of our oceans impact our weather and climate. And this is where we find out what's going on in our oceans. So we can see the La Nina has ended. We're on El Nino watch. And it also tells us about the Madden-Julian oscillation. It's currently very strong over the Pacific. That generally impacts areas further to the north, but sometimes we can have rain spin off from that. So that can bring rain or dry conditions. The Southern Annular Mode does impact the south. And then the Indian Ocean dipole isn't active at this time of year. So we don't need to necessarily worry about that for at least a couple more months. But there's just a good summary here of what's going on in the oceans. And then if you want to know more about the Pacific, so for example, this is what Tim showed earlier. He showed a slightly different one, this International Climate Model forecast. It just shows, is it likely to be La Nina or El Nino, and you can select the month. So here we can go May, June, July, and we can see by July, most international forecasts do have us going into an El Nino. So this is the Bureau, Canada, Europe, Japan, France, US, and the UK. And this is the model forecast out of just the BOM. And so El Nino is indicated in red. We can see all those little squiggly lines are in red. So essentially our model is very strongly indicating an El Nino. There is something to be said though for this time of year. It's kind of a funny time of year. They do call it the autumn predictability gap, because essentially what's happening is our oceans are like shifting around and figuring their stuff out, and there's all this sort of stuff that can happen in the meantime, this chaos in our system that at this time of the year especially can really come into play and change up what's going to happen. So we'll take a look at the rainfall forecast now. I'm just going to go back to the home page and show you how to get there again, because sometimes it's good to see it a couple times. So the home page, halfway down, climate and past weather. So we just looked at this climate driver update. That's where all that ocean information was. And now we're going to look at this long range forecast. So we'll click on that. And we're just going to start with chance of above median. It's a pretty basic one. It doesn't provide a huge amount of information, but it's a good point to start. Okay, and now we see that we have forecasts for 1 week periods. So they're past our weather forecast. So weather is just the next 7 days. So this is a 7 days beyond that, or the fortnightly periods beyond that out to weeks 3 and 4. Then we also have 1 month, so April, May, and 3 months, so seasonal. Now we look at these and we go, oh gosh, that doesn't look so nice, does it? But interestingly, they have changed so much. We'll talk about them really quickly, and then I'll show you. They've actually, if you've been keeping an eye on them for the past maybe 6 weeks, every time they're issued, they look quite different. And that's just reflecting this uncertainty in our system. Even though everything's saying, yes, El Nino, El Nino, El Nino, and that's quite likely to happen, there is still just a bit of chaos swirling around in there. Okay, so let's just take a look at Maury, for example. The easiest way to find where you are is to click this little search button. And then you can type in a name or your lat long. So if you're on a property, that can be really helpful if you know your lat long. I'm just going to use Maury. And it takes a moment to think. So you always got to give it a moment or two. Ah, there we are. Okay, so now we're looking at the
Chelsea there a little bit as it's starting to load up. You just started to break down.
Okay. Am I better now? Maybe I'll just turn off my video real quick. That might help. But thanks. Let me know again if that happens. Okay. Is it coming through now? Okay. Pippa, give me a thumbs up if it is.
Great, Chelsea.
Yeah, you're good.
Great. Okay. Cool. Okay. So we can see the outlook for April to June at Maury. The historical median, because that's important because this forecast is for chance of exceeding median. So we need to know our historical median. Historical median is 98 mils. So sometime between April to June, Moree tends to get in 5 out of 10 years, 98 mils. That means in 5 out of 10 years, they're going to get at least that much, so more than 98, and in 5 out of 10, they're going to get that much or less. And then we have a few other bits of information here. So chance of unusually dry, which in this case for Moree means less than about 63 mils. There's a 36% chance of that happening. Chance of above median is about 27, and chance of unusually wet conditions is only 4%. So very quickly, I can look at this and go, if I need a lot of rain at Moree in the next 3 months, I'm probably not going to get it. So this might impact, which crops you're going to plant over winter, if any, and just sort of help guide ideas like that. And so if we look at this chart down below that says deciles 1 and 2, 3 and 4, 5 and 6, this essentially just breaks up historical rainfall into different boxes. So if we have 100 years of rainfall from Moree, and we line it up from lowest amount of rainfall to highest amount of rainfall, for this one specifically for the months of April to June. So 100 years of rainfall data from April to June for Moree, lowest to highest. The bottom 20 years, so the lowest rainfall for 20 years will be deciles 1 and 2. So what this is telling me is in Moree, the lowest 20 years have seen less than 63 mils of rain. The highest 20 years, so deciles 9 and 10, have seen more than 146 mils of rain between April and June. Because now we've divided that, let's say, 100-year record up into 5 equal boxes, there's now a 20% chance of having any of these. So it says that right there. Usual chance for each range is 20%, and they've drawn a little line there. So essentially a 36% chance of being in deciles 1 and 2 is nearly twice the normal likelihood, because the normal likelihood is 20%. If that doesn't make sense, let me know. I can explain it more later. But essentially, it's just saying the odds have shifted to drier conditions, and they're shifted away from unusually wet conditions. That's a very easy way to interpret that. Okay, but so now let's that's sort of our seasonal forecast. We can look at just the month of April if we want, see how much longer of the season we have. I know for me, I would like a bit more of the season. We haven't had a lot of rain. I'm on the Sunshine Coast since about January. It's like a tap shut off, and I am not impressed, let me tell you. Okay, so for April and Moree, the historical median is 22. And pretty much the odds are kind of even. They're shifted slightly lower into this lower decile, but they're kind of more or less even away, but unlikely to get more than 50. So you can think about your soil profiles and use that as a bit of a guide. One thing that I really like on this webpage, so I was down in Moree not that long ago and was talking to some cotton producers. And I feel like what producers always want to know is, it's really nice to know when we're going to get rain in the next 7 days. That's great. But then when are we going to get that follow-up rain? And I think that that's a really good question. So I'm kind of moving away from the next few months. This is kind of, you can use it at any time of year. But you can get that information, that follow-up rain information, or at least, a bit, on this webpage. So if we look over here on the left, there's a few different options. So we were looking at this chance of above median here. Chance of extremes, you can look at unusually dry or unusually wet. But what I want to point out is this chance of 3-day totals. Okay. So this is a really good way to know if you're likely or not to get follow-up rain. Because we can use that 7-day forecast to know if we should plant or do whatever. But, we need to know, are we going to get rain after that? So what this does is this tells you the chance of getting at least a certain amount of rainfall. So it can be 15, 25, 50, or 75 mils in a given 1 week or fortnightly period. And the way that this forecast works is that rain, so that 15 or 25 mils, has to fall within 3 consecutive days. Okay, so right now what I'm seeing, actually for the 25th to the 31st of March, there's a 40 to 60% chance of getting at least 15 mils in Moree. That actually won't help me. So this is just a really nice little tool that can tell you, you know, are you likely to get that follow-up rain? We can also look at, interestingly enough, there's actually, for that time period, 25 to 31 March and Moree, the odds have shifted to be in those upper deciles. So interesting. Of course, the historical median is only 2. Got to take that into account. But yeah, but so we can see, you know, when are we likely to get more rain or less rain in terms of follow-up? Cool. Okay. That's all I'm going to say, I think, about the BALM website, just because I just want to take 2 minutes and quickly point out another website that we use. If anybody wants me to come back to this, we can do it in the question and answer. But so this is another website that I use just to make sure that the BALM is jiving with other models, because essentially around the world we have all these different models and they generally have similar data that goes into them, but they're all programmed slightly differently, and so the outcomes are slightly different. So this one is out of Europe. This is the European Center for Medium Range Weather Forecasting, and it is arguably one of the best in the world in terms of being correct. And it also, the benefit of this one, it goes out 6 months, so it goes out longer than the BALMs. So this is for April, May, June. And instead of just looking at above or below median here, we're looking at, is it going to be unusually dry? So bottom third of years, middle third of years, so kind of normal, or unusually wet. We can also look at median, but I'm just showing something a bit different. So this is showing for April, May, June. Much of Western Australia and Central Australia are likely to be on the drier side. For the East Coast, it's a bit up in the air at this point. Okay, then we can go to the next month. There we are. Now we can see May, June, July. The chance of being unusually dry has increased for most of Australia. Again, along the East Coast there, it's still kind of iffy, but this is a vibe, right? So we're seeing generally dry conditions are around. So that means that there's less opportunity for moisture to be around as well. Okay, then we can go at June, July, August. And the last one is July, August, September. So there's no real indication between now and September that it's going to be unusually wet. And I guess that's kind of the point I want to make here is, you know, we are seeing that the odds are shifted towards drier conditions. This is likely a reflection of that El Nino that's being forecasted. If suddenly that forecast for the El Nino changes, we'd likely expect to see these forecasts change as well. But right now we have the BALM showing it's likely to be dry. We have Europe showing it's likely to be dry. So I'm going with the dry vibe. Thank you.
Thanks, Chelsea. That was really interesting. I find the BALM, as you said, it is a bit of a beast. And so knowing exactly where to go on the kind of really relevant and specific information for our region or your property even, it's there. We've just got to know where to look. So you probably helped to clear that up for a few people, including me. So
and also I'd like to, thanks for that. I'd like to point out, Vicki also sends out a fabulous newsletter that has links to certain things in it. So that way you don't actually have to remember how to get there. You can just click on the link. So talk to Vicki if you're interested. Thank you.
Even better. Thank you very much. Great. Next up, speaking of Vicki, Vicki Mayne is going to present to us. She's a Wagyu beef producer on the Western Downs, and she's also works with the Climate Mate within the Northern Australian Climate Program. As a climate mate, Vicki's aim is to help other producers and red meat industry stakeholders throughout southern Queensland improve the use and knowledge of weather and climate forecasts throughout engagement and training. So, Vicki, I'll just hand over to you.
Thanks for that, Pip. I'll just get my screen sharing here. Okay. Can everyone see that okay? Can you see the PowerPoint?
Yeah.
Fantastic.
Yeah, thanks.
Yeah, so I'm going to just give a 15-minute presentation on how to decide which forecast tools to use and which are beneficial to assist with your decision making. But I'm going to start by just asking you the question first. When you hear Tim or Chelsea mention the word El Nino, how does it make you feel? Like, what sort of thoughts go through your head? Do you feel a bit like this guy? Or do you feel a bit like that? You just want to stick your head in the sand and not think about it and just pray that the rain will come. So there's so many tools, apps, websites, you know, resources, extension programs. The list is just endless, especially when you start to add social media and the likes to the mix. So which ones will give you the answers to help you make those decisions? I'm going to be a bit controversial here, and I'm going to say that there's none. But what I mean by that, unless you can answer these few questions first. So what is your average and your median rainfall and temperatures for your locations? It's really important to know that. Do you understand the difference between what average versus median is? What's your current condition of all parts of your business? You know, not just your pasture or your livestock, but also your financials, your staff, family, and all those intricate parts of a business. What's your current stocking rate? Is it sustainable? You know, what risk or extreme is it that you're trying to manage or mitigate? And what proactive or financially viable decisions are you looking to make? What information and resources, knowledge or skills can actually help you to make those proactive decisions? You know, they question when is the right time of year to look at the climate drivers and the outlooks? When do you need to start to make decisions? Do you actually follow through and implement those decisions? And why? Why is your country in the condition it is, given the season that we have, you know, be it good or bad? You know, if you're looking fantastic and you've got really good pasture growth, what is it that you're doing right? If it's not so good, you haven't been getting the response, but you've had the rain. Why is that? What management decisions have you been doing in the past that could be lending itself to that condition? And what are you worried about? You know, what is it that will help you sleep peacefully at night there? So, you know, when we're looking at some of these questions that we ask ourselves, we've got to look deep and hard and have that honest conversation, not only with ourselves, but others that are in our business. And we need to start to let our head rule, not our emotions, because if we let those emotions rule, that's when we start to, you know, feed stock when we really can't afford it. We degrade our land and we hold on, just praying and hoping that those rains will come. But if we start to use our head and we combine it with data and really good, reliable and reputable science, combined with our intimate knowledge of our business, our history and our available resources, then we can really start to, you know, fit the pieces to our puzzle a lot better. And, you know, looking at our seasonal outlooks and forecasts and trying to be on that front foot rather than be caught on the back foot is a bit like putting a jigsaw puzzle together in some respects. You know, so you've asked the questions, you've got some answers. Now, where do we go? What's our next move in finding the right piece of the puzzle that can help us with our decision making? So you've heard from Chelsea there, and it's really simple. We're going to keep it simple with what resources and tools are there. So we've showed you the outlook there, and it's a really great resource, you know, of looking at the fortnightly, monthly and seasonal outlooks. It also provides those historical medians for you. And, you know, let's just, for argument's sake, that you've watched the webinar, you know, webinar's over, you've gone out, you've had a look in your paddock, you know, you've actually stepped out of the utility, or, you know, you've stepped out of the saddle and had a good walk across your land. You've had a look at your livestock. You've delved a bit deeper into those cash flow budgets and things like that. So we can tick all those, and you've made some notes along the way, and they've provoked a question or three. So where to next? So that's where we're going to start to look at how does the season compare historically for our rolling rainfall. I've been hearing that, you know, down in your neck of the woods, I'm up here just northwest of Chinchilla, and that it's been, you know, really dry, unusually dry. So let's pop in there and have a look to see just how dry it is. And I've actually prepared earlier that this is the Australian Climate app. Now, it's a really good little resource. It's got a suite of analysis tools that are in there. And if we have a look, it's also got some wonderful clickable links and information to, you know, a plethora of very good, reliable and reputable resources there. So we'll jump across and we're going to have a look at how is the season comparing. So I've just gone and I've popped Narrabri in previously, and I'm looking at the rolling rainfall. I don't like to look from January to December. I like to look in those, you know, what is my rolling 12-month average looking like? So this is a wonderful little tool, analysis tool that you can see. You've got a variety of ways of seeing that data. So you've got drop-down boxes and you can choose, you know, all the way up to a 5 years hindcast there. But we're just going to look at that 11 months and looking a little bit 6 months. So we can see our current values. We're actually sitting in the 83rd percentile, you know, for our rainfall. So the current value as of the 20th of March is 766 mils. So we're 185 mils above the median there. And this red line, it actually shows you how that rain's fallen to date. And we can see there that things were, you know, ticking along nicely. And then you had quite a significant jump of 100 mil there. Back in December, it slowly started to tick along, and these flat lines, it's basically where that tap turned off for a while. So you've had a couple of those incidences where that tap has really turned off. You know, we see here, we just move this mouse slightly back, it's a finicky little beast. On the, you know, it's roughly about the 26th of the December there, you were 652 mils, and, you know, you only managed to get 8 mils through to, looks like there was the 30th of January there. So you had a month of not much happening whatsoever. If we have a look, this top line, that's actually back 2011, 2012. If we have a look around the same time of year, it's sitting at 997. And this bottom one down here is the 2002, 2003. So each one of these lines represents an historical point in time and compared to rainfall. And not only rainfall, you can also have a look at your temperature as well as radiation and heat sun. So then we have a look and we think, well, righto, you know, we're having, you know, an above median rolling rainfall. You might think, well, you know, why are things looking so bad? So you might only want to just drop back to 3 months ago and think, you know, where did it go pear-shaped? Was it summer that actually, you know, lended itself to looking so dry? So apologies, I've got slow internet here. And then we can start to see that, yep, our summer, it was sitting back that December through to March back in the 22nd percentile there. So we had about 79 mils below our median for that period of time. So you've been hearing the words El Nino and neutral, and what does it mean for that Narrabri years? So we can have a look, and you can jump in here and you can put up, you'll see I've got a you know, heap of history here that I've looked at it for different producers of where I've looked at, but you can choose your location by hitting that select or edit new location. Unfortunately, it doesn't let you put in your postcode, so you've just got to go in and type. If you put in your postcode, it seems to bring up really random places. So start typing in your location. But we're looking at just Narrabri for argument's sakes, and I've actually put in from 1970 to present, and we'll get to that in a moment why, but it can go back to the last 120 years, back to 1900. And again, you've got some different visuals of how to look at this depending on what you like. So we see here, I'm just going to put up, for all years of data for starters, that if we look at July, we can see that median rainfall, so the little pop-up blocks here is your rainfall, and you move your mouse over. The little yellow line is your minimum temperature. The thicker, lighter blue line is your evaporation, and the red line is your maximum temperatures. But we'll just concentrate on rainfall because we've only got 15 minutes. So it's 41 mils in July, 33 in August. And if you look at September, use it as an example, it's that 40 mils. Okay, so what will it mean for El Nino? What, if it does push over and does go to El Nino, what does it mean? We can see there that we've jumped from that 44 back to that 28 mils with a historical median for that period from 1970 through to present. So just be mindful that this here is based on what hindcast period that you actually choose there. And if we come down a little bit further, you can start to see these blocked in red is those El Nino years that have actually occurred since 1970 through, and what the rainfalls were. And you'll see that not all El Nino years mean rainfall deficit. We have a look here in 2005, there's actually 248 mils fell in the December. And that's those outliers. So I have to correct myself here. When we talk about these, the millimeters here, it's actually averages, it's not median, which is quite frustrating because how the season is in median, but back here, it actually is bringing in those averages. So that's when you really need to think, well, why is December, sort of appearing to be one of my wettest periods for an El Nino when it wasn't in all years phases. And that's because of these outliers that crop up. And we can see there was, in 1991, there was 211 in May. So it doesn't necessarily mean that the tap's going to shut off, so to speak. If we go and have a look at, okay, we're in neutral territory, what does it mean? That's where we're sitting right now. So what does it mean? We're on that El Nino watch. Just wait for it to load up here. And as I said, we're just focusing on rainfall, but you can change that up to temperature and evaporation. So if we have a look, you'll notice here that the rainfall actually crept up a bit for July, and did tend to come back, but it crept up a little bit more than compared to an El Nino for that September. And again, it pays to go down and have a look at, are there any significant outliers? And we can certainly see there's been some big falls that have fallen historically. I'm just going to put back in here the La Nina. Lou had asked, Pippa had asked me prior to the webinar, how often do we get an straight to an El Nino, follow 3 years of La Nina? So if we have a look, the last time we had the 3 years of La Nina was sitting back from 1973 through to 75. And so we're interested in this 1976 period of time. What actually happened? Well, if we jump back up, we'll actually see that it was a neutral year that followed along. And then it was this next year, that 1977, if we were to change things up, that moved to El Nino. So this is just one little tool. As I said, there's some fantastic analysis tools that you can look at there. And especially if you're looking at forage crops and things like that, you've got potential yields, also your nitrates and things like that. And you can look at your trends. So this is quite a good little resource to start with. I'll just see if I can jump back to my PowerPoint just really quickly. I just want to show you can start to, if you're looking for a GISMN or you've got multiple properties, you can take screenshots, put it into a document, and you can start to compare, across regions and even across states with that tool. So it's quite handy, especially if you say, it's neutral, you haven't got a lot of vegetation happening, not a lot of pasture response, and you think, right, well, I've been offered some, and I'm located here at Narrabri. I've been offered some adjustment over at Armidale. What does neutral years look like, you know, for Armidale, and as far as rainfall and temperatures, and even into El Nino years. So it gives you a visual to start then doing further homework. And that's me. So I hope that was a good little quick resource. There's plenty out there, but it's a good starting point.
Thank you, Vicki. That was really interesting. They say knowledge is power, and I think when it comes to climate and farming, there's definitely a lot we can do there to help with our decision making, particularly, I guess, with this season ahead. So really appreciate that quick presentation. Next up, we've got Lou Hogan. So Lou is the node manager for the Armidale node with the Southern Queensland, Northern New South Wales Innovation Hub. Lou is based out of Armidale. She's responsible for delivering programs like Ag 360, which she's going to talk to you about, and the Farming Family Reboot, which is another program she delivers. So Lou, I'll leave it with you.
Thanks very much, Pip. Can you hear me?
Yes.
And you can see the screen?
Yes.
Great, thank you. Thanks everybody for the opportunity. I wanted to give you a brief introduction to Ag 360 today. This is a web-based software tool that was originally developed by the Sheep CRC, then handed on to UNE and further developed to be suitable for all grazing livestock, sheep and cattle. And really, both Vicki and Chelsea and Tim have talked today about the climate systems and the forecasting. And I guess what Ag 360 does is take that forecast in terms of the weather, the rainfall, obviously, but also all the other variables like minimum, maximum temperatures, etc., and really apply that in your farm situation. So you combine the weather forecast with management information from your property to get predictions around what's likely to happen in terms of productivity of pastures, soil moisture, and all growth going forward. So it's really quite integrated and takes that climate forecast and rainfall forecast particularly to a new level of insight for helping you make good management decisions. So I'll just change now. So this is what the open website looks like before you create an account. I should say at the outset that it's free because we have support from the Southern Queensland, Northern New South Wales Innovation Hub via the Future Drought Fund money. It covers the maintenance costs of this system, and that enables us to provide it free to farmers right across Australia, which is a great outcome out of the Future Drought Fund. But once you've created an account, you locate your property using Google Maps with an address. And then you start to map your paddocks and add in your mobs of animals. And what we have is a weather data set similar to what you've seen in the other presentations, but ours is downscaled to a 5-kilometre grid right across Australia. So what it means is that the rainfall forecast and the weather data that's being used in the models is very customised to the location of your property. So it's not at that broader scale of rainfall prediction that you might see on the news or on some of the weather apps that are at a broader scale than that 5 kilometres. So that is one difference in terms of our weather forecast and why you might sometimes see differences between the rainfall outlook here and some other systems. So for today, I've just created a little demonstration file at Moree with 2 paddocks. You can see one paddock has subtropical pasture in it. The other one has winter active or temperate pasture in it, and they've both almost the same size. And I've put 50 steers in each paddock to give you a demonstration of what happens, and we'll go through some of the predictions shortly. But I just wanted to show you the rainfall outlook first. Remembering that we're at that 5-kilometre grid scale, and this is showing me for this location, it's all interactive, but if we're here today on the 21st of March, where there's been 42 millimetres in the previous 40 days, based on the Bureau's interpolation algorithm for this location. And to the right, you can see this is the forecasted for rainfall out to September, so for the next 180 days. And we're showing you the median prediction, up to 181, the 25th and 75th percentile. So a band of potential outcomes in terms of rainfall. And that 181 there includes the 40 millimetres that I said had fallen in the previous 40 days. So between now and September, at this location, about 140 mils of rain is the median prediction, which is not a huge amount. This is updated multiple times per day, so it could be different every time you come in here because we're always absorbing new information from the Bureau to update this forecast. And what we do once we've got this rainfall outlook for the property is based on what you've told us about each paddock, we provide an estimate of soil moisture on a paddock by paddock basis. So you've told us the soil texture, some information about the history of the paddock in terms of productivity of pastures and what grazing history has been there. And our soil moisture model gives us a prediction about soil moisture, and we can see that from the surface. I'm showing you through the 60 centimetres, but we could go to a metre of depth. And what you can see is that there is moisture at depth because we've just come off a very wet period, as we know. But certainly that top 60 centimetres, with the exception of this rainfall event that happened in the last couple of days, there's really not a lot of soil moisture there. And through this key cropping period here, not much soil moisture in those upper layers. And I guess everybody would be aware of that at the moment, given how dry it's been and the way everyone's suddenly getting very concerned about outlooks for rainfall. The other thing we can show you is a comparison of the current year to other years, and Vicki showed you something very similar on climate, but you can start this at any date that you like. So I'm just going to start in the start of spring last year, and you can see that these are cumulative rainfalls for any of the last 30 years. The black line is the current year and includes the forecast. It doesn't go out to September yet, but it will soon. It only goes out to June at the moment. And you can compare to any other year and see what it's looking like compared to. So it just gives you an idea of how does this year track compared to others in our history or in our memory of managing property, and very useful for people making plans and thinking forward about how do they react to the season that's coming at them. The other thing that we do in Ag 360 is add a rain gauge. So you just go over here and add a rain gauge, and this is a rain gauge here. If I right-click on that, I can get the Bureau's estimate of rainfall at this location on a daily basis, and this gets updated automatically every day from the Bureau, and it goes back, any number of years. We tell you what the minimum and maximum temperatures were as well. Now, if you've recorded a different rainfall to what the Bureau has estimated at your location, you have the ability to come in here and record an observation. And once you've done that, our models will use that entry rather than the Bureau's for rainfall to use in the models. So you have the ability to put your own information in and influence the predictions based on what you've seen happen at your place in your own rain gauge. So that's in terms of the weather information. I've shown you the soil moisture information. In terms of the paddocks, there's some data we need to be able to predict effectively for pasture in that paddock. So I'll just show you this entry here. So we've mapped the paddock, we've got the area, the proportion of the paddock that is grazable. And then we ask you to describe the pasture in that paddock as either, and what proportion of it is temperate or winter active, so actively growing in the winter, versus tropical or subtropical, which means that it actively grows during the summer period. And then we ask you to rate the productivity of that pasture on this slider, 0 being the most degraded, least fertilised, poorest quality pasture in your district. Very important to remember it's in your district. And 100 would be a really highly fertilised, highly productive fodder crop in your district. So in general, even good quality pastures are probably in the 50 to 60 productivity slider range. And as you move this slider, you're changing energy, protein, digestibility of the pasture. And this is a daily growth chart for pasture, and it's sensitive to this productivity slider. So this is telling you what sort of daily growth rate you could expect in a pasture with a P slider setting of 50. And you'll see that it is responsive to this. So at the moment with a setting of 50 here, the this pasture, which is 100% subtropical, would sort of median growth rate would be about 15 kilograms of dry matter per hectare per day and nothing in the winter. If I put that slider up to 100 and refresh it, you can see we're up at around a median growth rate of about 25 kilos a day. And obviously, if I put it down at 0, it's very, very low. I'll show you that quickly. So that just gives you some help in trying to set that setting of the P slider, but it does take a little bit of time to get that appropriately calibrated to your system and your paddocks. So you do that on a paddock by paddock basis. Provide an estimate of pasture in the paddock. So I set this up for the 1st of September last year, estimated 3,000 kilos of pasture in the paddock, so about 9 centimetres. Rated the soil fertility. And if you have a soil test result, you can open this worksheet up here and enter the soil test results, and it will automatically position that for you. But you can use this qualitative scale as well. And then the soil type. So they're the parameters we need for each paddock to help the models run and make the predictions around pasture. You can set targets for some time in the future. So in this case, I've said I don't want to go below 1,000 kilograms of pasture per hectare at the end of June in 2023. You can keep records of fertilisers, chemical applications in those paddocks and print that out as a register if you were audited, or it's all consistent with what you need to keep in terms of records for compliance. So that's all there and exportable. So that's the paddock side. And then with the livestock side, we add mobs of animals. So we create classes of stock. So they could be breeding ewes, dry cattle, wethers, etc. So different classes. And then we add mobs according to the class that they sit in. So I've got 2 mobs here. I've got 50 steers in the tropical pasture and also 50 in the temperate pasture. They came in at 250 kilos, and I've set a target for them of 400 kilos by the 31st of March. We can keep, if we actually weigh this mob of animals, we can keep a record of that in the system, and it will show us a record and help to fine tune the models. So the date that they were weighed, or if the number in the mob changed, you can change the number as well. You can keep records of how animals move around paddocks. So you keep rotational records of grazing. We can record key dates like shearing, joining, landmarking, crutching, etc. And we can keep all the veterinary records as well. So I hope you can see that it's got the weather information. It becomes a really useful record of all the management activity that happens on the property. And then once we've got the management information, we can combine that by clicking on the predictions and risks. It will go away and use the rainfall outlook and all the climate predictors to predict a range of things. But, so, the key things that we're predicting are how much pasture will you have in the paddocks after we've accounted for what the animals need to eat and to grow, and what will those animals weigh. And we have some other animal health predictors out here that are primarily for sheep. So risk of fly strike, risk of cold stress in at lambing time or in newly shorn sheep, and the risk of heat stress in cattle. So if I just move to so we're in the predictive side now. If I look at the 2 paddocks, I'm getting green ticks. You'll remember that I set a target of 1,000 kilos per hectare at the end of the June. So there's my target out here. So remembering this is a summer active pasture that I started at 3,000 kilos on the 1st of September, you can see that it grew rapidly during the summer period because we had a reasonable amount of moisture, peaked out at about 7,000 kilos, and it's now declining as the animals eat the pasture in the paddock, and it decays as well, of course, because it's coming out off its growth phase. And here's our predicted pasture availability for the subtropical pasture going out to September. Once again with that probability band associated with it, because we have probability associated with the rainfall outlook. But we're looking very safe to be above our minimum residual target of pasture of 1,000 kilos. If I look at the temperate, the winter active pasture, it's got quite a different shape to it because it has a different growth pattern, of course. Sorry, So once again, starting back in September with 3,000 kilos, the animal, it did still grow during the summer period because there must have been moisture there, but you can see now that the animals have deteriorated, well, eaten a lot of that pasture, and probably it will have decayed as well. We're down to about 1,800 kilos. It's going to pretty much flatline from here out based on the weather forecast, but we're still going to meet that minimum residual target of 1,000 kilos, which has been set by the user. And then we can have a look at how the animals might grow. So the green tags were in the tropical pasture. So here we can see the prediction for weight in those animals. And look, they're still they're on target to be at that target weight by the end of March. So everything's tracking okay there. But in the temperate pasture, you can see we're getting more of a warning there, and that's really because we saw that pasture declining because it was out of its growth phase during the summer months. So they're going to be close to their target, but not quite there. So look, that's probably as much as I need to show you, but I really wanted to just highlight the fact that it's a way of integrating the climate outlook with our knowledge around pasture growth, animal growth, and a way to protect our soils and our pastures too from overgrazing and degradation by having that long-term 6-month outlook about what's likely to happen and to help with our planning activities. I just wanted to reiterate that it is a free product and that we can provide training and support if people would like to be helped to set up an account and start to use this. Although it is fairly straightforward, it's sometimes helpful to have some training and support. Thank you.
Thanks very much, Lou. That was really good. I love the fact that you can put in some soil test results and it tells you about analyzes your soil test, because I know you get soil tests done and then you give them to the agronomist and they tell you what to do. So the ability to use that information yourself is really good. And obviously there's a lot of information that sits behind these programs, and so it's great that we've got something free that we can use at a paddock scale and a property scale, particularly with that rainfall and climate information. And am I right, Lou, in thinking that in the email that follows the webinar, which has the recording, there'll be an option to join to let us know or let Lou know if you wanted to be involved in some online training for A360.
That's correct. I believe so, Pippa.
Great.
Yeah, that's right.
So,
we'll send out a PDF that'll go out in an email in the coming days with the link, and then all contact details to how to contact Lou for that training, and as well as other links that the participants have heard today.
Fantastic. We're up to a bit of a Q&A session. I see that there's been a few questions come through in the chat. Vicki, did you want to sort of read out some of those to the respective person, or?
Yeah, we will do. So our first one here that we had was from Greg, and well, actually, we'll start with the first one that did come through. Does El Nino only happen in the Pacific? So that's a Chelsea or a Tim question there.
Yeah, I can take that. So the El Nino Southern Oscillation describes the changes in the ocean and atmosphere in the Pacific, but it does have impacts outside of the Pacific. So not only does it affect the tropical regions, but it also affects what we call the mid-latitudes and the extratropics. And also El Nino and La Nina can influence other climate drivers outside of the Pacific. So there's a strong relationship between, say, El Nino events and positive Indian Ocean dipole events. So that's that. It's almost like an oscillation in the Indian Ocean. So, but the actual El Nino Southern Oscillation description describes what goes on in the Pacific.
Thanks for that explanation, Tim. Thank you. I hope that's answered the question there. The next question that we had came through from Greg, and Tim, I see that you said that you could answer that one. Greg asks, with global warming, surface temperatures will have increased. How do these increasing temperatures affect calculations of the SST anomaly? For example, is the mean constantly updated, or is the mean taken from a limited period in the past?
Yeah, that's a great question. And in fact, the Bureau were part of a workshop, was it late last year, that involved both partner agencies like NOAA, so the National Oceanic and Atmospheric Administration, agency in Singapore, and I think in New Caledonia as well. And that was something they actually discussed about standardizing the definition of El Nino Southern Oscillation, or at least the oceanic component of events. So the Bureau currently use a fixed 30-year, well, it's actually 1981 to 2018 set period, but other agencies like NOAA do use a shifting climatology, and in doing so, that does actually take into account the fact that the ocean has been warming since we've been taking measurements of the ocean. So to give you an example, you mentioned, Vicki, that Narrabri in 2005 had a bit of an unusual year, and I think December, in terms of it was quite wet. NOAA went back and they updated their sea surface temperature anomaly calculation, and they found that 2005 and 2006 with an updated climatology was actually a La Nina event according to their definition. And I think 2008 and 2009 was a La Nina episode as well. So yeah, this is something the Bureau is currently working on, and we will eventually join NOAA in using a rolling climatology to define our ENSO. A great question.
I've got two quick questions. One is for Lou, very quick, and the other one is for either Tim or Chelsea. Is Ag360, is it a desktop app or is it a mobile app? Just out of interest.
So Ag360 will work on any web-enabled tool, so it can work on an iPad or a phone. It's obviously quite cramped on a phone. So we are just starting a new project at the moment to develop a phone app, a specific app that will support it. So you'll be able to record your data online or offline whilst you're in the field, and get some pre-calculated predictions, but you won't be able to calculate on the fly on the phone. Yeah.
Okay, easy. The second one, we talked earlier, or you guys talked about Central and Eastern El Nino. Is it possible to know which one it is when we're in an El Nino watch, or is it not until it actually hits the ground that we can work out which one it is? Because I know that they have different impacts, obviously.
Do you want me to take that one, Chelsea?
Yep, that's fine. Go for it.
So the Bureau actually don't forecast whether it's a Central or an Eastern Pacific El Nino in their forecasts. So they do just monitor what we call the Nino 3-4 region. So that's sort of the central, so sort of Eastern Pacific box around the equatorial region. But we don't actually say anything in our climate, in our forecast summaries about whether it's a Central or an Eastern Pacific El Nino. But we do monitor the sea surface temperature anomalies, and and then as I said in my talk, the impacts can be quite different depending on what type of El Nino event crops up. But even in itself, El Nino events can actually have different impacts on rainfall and temperature. So it's not so clear cut, but yeah, as the Bureau doesn't actually sort of differentiate between the two different types in our forecasts.
Yeah, thank you. I think there was one other question from Greg as well about, with temperatures increasing over time across the Australian continent and the eastward flow of warming air off the continent, does this influence the Pacific SST, or does that answered in the last one? It's a separate question, but did you already answer that?
No, I didn't answer that one. Okay, so it's unlikely, given the Pacific makes up what 40% of the world's sort of surface area. It's a big ocean basin. What happens in Australia probably doesn't have a big impact on actual temperatures. But in saying that, we do see during, say, heatwave events, when you have really warm central Australian, the sort of like a heat dome over Australia, and that warm air gets sucked sort of downwards past Melbourne or into Adelaide, and that continues to flow out into the Bight. That can influence surface temperatures. So we do see local impacts on sea surface temperatures around the coastlines, but it's unlikely to have a broader effect on ENSO development. But there are other climate drivers that, I think Chelsea mentioned, the Madden-Julian Oscillation, which is a sort of a tropical mode of variability that sort of goes from the Indian Ocean through to the Pacific Ocean. That itself can trigger El Nino events. So smaller modes of variability can trigger the larger modes like ENSO.
Cool. I think that was all the questions. Vicki, did you see any more questions on there we needed to answer?
No, I didn't. But one of the things I might just ask Tim just to really briefly touch on, because we have got a few minutes to cover it, is what the forecast is looking like for a positive IOD, and how it those positive IOD and El Nino years. Just brief, Tim. Not much.
Yeah, absolutely. So they're at this stage, I think the models are indicating that there may be, we're heading into sort of positive IOD territory, but at this time of year, the model skill isn't overly great. So Indian Ocean dipole events, when it's a positive event, that means that the oceans in the Sumatra Java region, so eastern tropical Indian Ocean, are cooler than normal, and in the western Indian Ocean, they're warmer. And these typically go hand in hand with El Nino events, but they don't always have to. And these can, when you have a positive Indian Ocean dipole event and coupled with an El Nino event, you typically get really strong drying conditions over southeast Australia in the winter and spring, and then into summer can be followed by bushfire or a higher bushfire risk.
It's certainly a driver to, in the coming months, to start to pay a little bit of attention to not just all the focus on ENSO, because it does have an impact through that southern Queensland, northern New South Wales regions. I don't see any other questions there, so I'll throw it back to you, Pip. I'd like to thank you, Pippa, on behalf of the Northern Australian Climate Program, for inviting us to actually put together this webinar in collaboration with the local Land Council of New South Wales, as well as University of New England, and of course the Southern Queensland and Northern New South Wales Innovation Hub. So thank you, Pippa, for reaching out, and I hope that it's been very helpful. And And we'll certainly have contact details in the PDF and email that'll go out in the coming days. So I'll throw back to you. Thanks, Pip, for hosting today.
Thank you, Vicki, and thanks to all the presenters. Some really relevant, really timely information. So we really appreciate your time and knowledge today. And thank you to everyone who called in. I know it's a long time to sit and listen, but hopefully you found it really, you've pulled some information out of that you can take away and implement at home, or just help so next time you're looking at the various websites, you've got a bit more understanding of what all that information means. So, and thank you, for Vicki actually for pulling it together in the background as well. I think it's, really enjoyed the process, and I've learned something new. So thank you. And keep an eye out, everyone, for the email with the recording and the PDF link as well. And have a good afternoon. Thanks.
Thanks, everyone. Thank you very much for attending.